Hey everyone, welcome. Today we're tackling a neat problem called find triangular sum of an array. It sounds a little fancy, but the process is actually quite simple and visual. We'll break down exactly what it's asking for and how to solve it step by step. Let's get started. Okay, so the problem gives us a list of single-digit numbers. Our goal is to keep shrinking this list in a very specific way until only one number is left. That final number is what's called the triangular sum. So how do we shrink the list? It's a repeating process. As long as our list has more than one number, we're going to create a new, shorter list. Each number in this new list is made by taking two adjacent numbers from the old list, adding them together, and then taking the result modulo 10. Now, you might see this percent sign, which is the modulo operator. Don't let it scare you. In this problem, modulo 10 is just a fancy way of saying keep only the last digit. So if we add 7 and 5, we get 12. We just keep the 2. If we add 8 and 2, we get 10. We keep the 0. It's as simple as that. Alright, let's walk through the example from the problem description to see this in action. We start with the list containing 1, 2, 3, 4, and 5. For our first step, we'll create a new list. First, we add 1 and 2 to get 3. Then, 2 and 3 to get 5. 3 and 4 give us 7. And finally, 4 and 5 give us 9. So, our new shorter list is 3, 5, 7, 9. Okay, now we repeat the process with our new list. We take 3 and 5, which gives us 8. Next, 5 and 7 is 12, so we keep the last digit, which is 2. And 7 plus 9 is 16, so we keep the 6. Our next list is 8, 2, 6. We're getting closer. Let's do it again. 8 plus 2 is 10, so we take the last digit, 0. Then, 2 plus 6 is 8. The list is now just 0 and 8. One last step. 0 plus 8 is 8. Now our list has only one number in it. And that's our signal to stop. The final number, 8, is the triangular sum we were looking for. Just a quick heads up. We'll be walking through the solution using Python. But don't worry if that's not your main language. The logic is the same everywhere. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. The most straightforward way to solve this is to do exactly what we just did by hand, but in code. We can call this the simulation approach. The idea is to have a loop that keeps running as long as our list is bigger than a single element. Inside this loop, we'll build that new shorter list, and then just replace the old list with our new one. Then the loop runs again. Alright, here's the Python code for the simulation. It looks pretty clean, right? Let's break down exactly how it works. First, we have a while loop. This is the part that says, hey, as long as the length of our list, called nums, is greater than 1, keep doing the stuff inside me. This ensures the process repeats until we have our final answer. Inside that loop, the first thing we do is create a fresh, empty list that the code calls new nums. Then, a for loop goes through our current nums list. For each position, which we call I, it calculates the new value by adding the element at I with the one right next to it, at I plus 1, and then doing the modulo 10 operation. It then adds this new value to our new nums list. After that inner for loop is done, our temporary list, new nums, holds the complete, shrunken version of the array. The final, crucial step inside our while loop is to replace the old nums list with this new one. The while loop then checks its condition again, sees that the list is still bigger than 1, and the whole process repeats. Eventually, the while loop will stop. This happens when our list has been shrunk all the way down to just one number. At that point, the code simply returns that single remaining element, which is the element at index 0 of the list, and that's our answer. So, let's talk about performance. The time complexity is big O of n squared, v core. Why? Well, the outer while loop runs about n times, where n is the initial number of elements. And the inner for loop also starts off by running about n times. A loop inside a loop generally gives you that squared complexity. For space, it's big O of n because we create that temporary new nums array, which at its largest is nearly the size of the original input array. Alright, as promised, here is the full solution in Java. This version is a bit clever. It modifies the array in place to save space by decrementing a counter n. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. This logic is very similar to our Python example, creating a new vector in each step of the loop. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Just like the Python and C++ versions, It follows the simulation logic directly, by creating a new temporary array in each iteration. Hopefully, seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The main takeaway here is that sometimes the most direct approach is the best one. We just simulated the process exactly as the problem described it. We also saw how the modulo operator is a handy trick for getting the last digit of a number. This pattern of iteratively shrinking a problem until you get to a single answer is super common, so it's a great one to remember. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.